Good evening, everyone.
Hi, Harry. Good job so far.
Hey, Bill. Everyone meet Bill, our very personable faculty advisor. Members of the faculty, family, friends, sponsors, good evening and welcome. My name is Yuri Slabicki, and I'm the team leader for this season of the Rensselaer Motorsport design. And I'd like to thank all of you for making it out here this evening for our event. We've been working on this car for countless hours over the last few months, many sleepless nights, and we can't wait to be able to show off the fruits of our labor to everyone here. This really is a labor of love, and none of this would be possible without the support of every single person in this room. And thank you very much for all of that. Going into this year, the team was in a rather curious position. Following the election of the leaders at the end of the season, we found ourselves with a 100% turnover rate. Every single leader from the past was either graduating or they were off a semester for the co-op. So we were left with a completely green crew. We came into this with the understanding that the team, naturally over the course of 4 years, as everyone passes through school, is going to have a complete turnover, but none of us were really prepared for the fact that every single one of us would be completely fresh. But however, I am very confident in saying that every single one of us has been able to grow into our positions both as members of the team and as an entire team itself. With this massive change that came upon us, we thought to ourselves what other changes could be made for the betterment of the team. We decided that we had a unique opportunity to, in essence, reinvent the team. The most evident way that we've done this, as you will soon see, is the redevelopment of our chassis. For the past 10 years or so, as you've seen upstairs with RM20, our chassis has been a hybrid monocoque. We have these carbon panels that are bonded in to the frame in order to add rigidity. This came around when a sponsor provided us with these panels, and we incorporated them into the design, and then a few years later, that supply ran out. After which point, we kept on going with the design, even though we had to continually purchase those panels and install them through a long and arduous process, not because we necessarily felt that it was the best decision, but because as a team, we really actually didn't know how to do anything else. The members who had the knowledge of making a traditional chassis had all graduated, and that knowledge left with them. This year, we decided to go away with the practice, essentially going back to the basics. So we transitioned to the space frame, which you will soon see. Our new designer, whom you will hear from very soon, took the challenge upon himself to reinvent how the chassis works, and it creates a foundation that we will continue to build upon for the future. With this new design, we also implemented a series of documentation guidelines. All designs that we put out this year, and hopefully for the future, will be accompanied by a design report, which is going to adhere to the standards set by SAE, the Society of Automotive Engineers, which runs our competitions. This new workflow will allow for a streamlined and consistent information transfer from year to year to year, so that 6 years down the line, new freshman can look at the report for the bell cranks and see what was done differently, what we thought we could change, all without having to scratch their head and wonder. And this new innovation will forestall the problem that the teams run into in the past of the loss of the information transfer. Another choice that drove our team this year was to alter our competition schedule. In the past few years, we've consistently attended Michigan competition in May. This year, we made the decision to step it down a notch and attend Formula North, which is a slightly smaller competition. It's held in Ontario. It's smaller, it's closer, and most importantly, it's weeks later than the Michigan event, which allows us for more testing time, more time to validate our designs, and more time to break things so they don't break at competition. And the most important facet of this also allows us to potentially change our entire competition schedule for the future. We'll be able to implement a 2-year design phase for the car. So we take the car to competition 1 year, then we improve the design, and then submit it to yet another competition with a vastly superior and more reliable car. And this also will allow us essentially to keep to a more hybrid schedule, catering to the skills of the team at the time. But no matter what happens down the line with the team, what's really important is the young men and women that are standing by me now and all the work that they've put in. And on that note, I would like to introduce our chassis suspension and aerodynamics design leader and returning speaker, Jay Marion.
Good evening, everyone. As you already mentioned, my name is Jay Marion. I'm the chassis suspension and aerodynamics design leader for Rensselaer Motorsport. And I just want to once again extend a warm welcome to family, friends, and distinguished faculty here tonight. So some of you who were here last year may remember I spoke as a freshman regarding my initial experiences with this team. And hopefully I speak for this year, the first year members, when I say that this team provides an incredible platform in which to build teamwork and engineering skills and apply them towards your passion. For many of us, design and manufacture of this car it's really a healthy obsession. We have worked in front of computer screens and machine tools long into the night since August. On any given weekend, recycling bins in the shop are overflowing with empty cans of both energy drinks and aluminum scraps. In industry, it's not uncommon to develop a single component of a subsystem over the course of a few months. Yuri was talking about how we were going to be switching to a 2-year car, but this car here is in the first year of a 2-year plan. So every component on this car has been developed under the course of a 10-month design phase. And that is going from design, manufacture, and testing of the entire student-built race car in just those 10 months. I'm extremely proud of this team and the vehicle that we are about to unveil. I'd like to share some of the design process and the main goals we set out to accomplish when we sat down on the drawing board last June. So the chassis and suspension of RM291 are designed to be as light, cost-effective, and easy to manufacture as possible. Emphasis was placed on design changes that improved reliability and production time in order to maximize available testing before competition in Canada this June. These changes began with the chassis construction itself, as Yuri discussed. Since 2004, we have used that hybrid frame construction with carbon fiber honeycomb panels bonded in. This is the first Rensselaer Motorsport vehicle to step away from that hybrid construction in the last decade. By removing the carbon panels, we have saved the team over $3,000 in manufacturing costs and reduced precious manufacturing time. The tubing was shifted in favor of a lowered front roll hoop and low slung side impact structure, which affords 40% reduction in frontal blind spot from RM20, which is the car you saw in the lobby upstairs. In engineering, we all know nothing comes for free, and these changes from the carbon panels to a space frame design mean that the chassis will not be as stiff as previous vehicles. It also means that an entirely new bodywork system had to be engineered and developed and manufactured in order to work and enclose and protect the driver for this year's vehicle. So the bodywork and aero kit is a big part of what makes this car really special in my mind. It's the first car in years we've produced that has a unifying aesthetic, a distinctive look that sets it apart from anything we have ever built. The body panels are single-ply carbon Kevlar fabric formed in-house via wet layup process. All parts of the process, from CAD to mold manufacturing to the layups themselves, were done in our own shop. There are over 20 different composite components on the car. From the seat to the steering wheel, from the end plates to the main wing elements, each one serves its own purpose in both form, function, and lightweight efficiency. Underneath the bodywork, we have done work to improve our suspension handling characteristics. Simulation began early in the first semester to model tire performance from data from the Tire Testing Consortium. Our models allow us to predict how our tires should behave under different cambers, toes, and slip angles. This analysis was used to drive determination of the ARM geometry and the bell crank geometry. both of which were optimized for steady state performance during skid pad. One of my favorite parts of this team is bouncing ideas off one another and working through design problems by saying, what if, and moving forward from there. With RM21, we wanted to improve our time and acceleration event by stiffening the rear suspension to promote rapid weight transfer to the driven wheels. One of the traditional options is to swap stiffer springs into the rear, but this isn't really practical for a competition because you need to rebalance the car and it takes a lot of time. So it's not really a realistic option. Our solution was to implement dual position rear belt cranks that use the same pull rod and the same hardware to effectively have two motion ratios. All it takes is a single bolt, a few minutes per corner, and basically what started as a what if has turned into a reality, and we look forward to validating our design come testing in the coming weeks. And with regard to testing, our vehicle simulation has allowed us to more accurately predict performance characteristics even before we hit the tarmac. Hopefully, in the reception, you guys were upstairs, you saw the computer running. That is actually a model of our car. It has all of the suspension characteristics, the brake characteristics, and the engine drivetrain shift points. They are all correct. We are currently working on modeling an effective map of the race course in Canada. So we'll be able to drive our car on the track that we will be competing at before we even get there. What this means is that new drivers who have never driven the car, or even drivers who have driven previous vehicles, will be able to get a feel for roughly what the car is supposed to feel like. And considering the fact that no drivers on this team are really very experienced, and autocross times generally dip below 60 seconds, and 1 or 2 seconds is the difference between first and 10th place at competition. Nearly all of our drivers are going to benefit from this sort of simulation. The strides we make with this simulation are actually, in some ways, with regard to our performance at competition, equally valuable to the design engineering decisions we make on the vehicle. So as we race ahead into the second half of the semester and the testing phase, it's important to reflect upon our goals and what we've accomplished so far. We set out to build a steel space frame chassis that built upon existing knowledge and was packaged in a lightweight, cohesive fashion that looked just as fast as it drove. Our end result is a car that I personally believe brings us in line with some of the top competitors in international competition. I want to thank all the team members, faculty, family that helped make this car possible. I think I speak for all of us when I say I cannot wait to see what the next 2 months has in store for this team and this car. Thank you. I'd now like to introduce everyone to our engine, drivetrain, and electrical design leader, Jake Kalish.
Hello, my name is Jake Kalish. As Jay said, I'm the engine, drivetrain, electrical design leader for RM21. I would like to get across the type of character it actually takes to be an FSA team member, and then I'll get into the technical details of the engine, drivetrain, and electrical. The majority of these team members chose to give up their weekends where they could be having a typical college experience, and they traded in for an atypical one. They traded in for a weekend of hard work, and when the weekend is over, they resume their intense workload from classes, and they still somehow are able to, they resume their intense workload from classes and are still somehow able to work on design, call sponsors, make purchases, and occasionally sleep. It's hard work, and it takes a toll. Tensions rise, grades fall, relationships suffer. Why do we sacrifice so much for a car? When the cover is removed and the car is revealed, it will all make sense, because it's worth it. The experience that all the members of FSAE gain from being part of the club is just as, if not more valuable than the education we will receive. It is an extremely practical application of everything we learn in class, and it teaches us a lot about the things that would typically be learned in industry. It is for this reason that the majority of the team members that gave it their all land awesome jobs, because it's a type of character and personality that has become hard to find. Without the hard work and sacrifice from all the team members, this car would not be possible, and it definitely would not look as good as it does. My design goals for the year were simple: to redesign anything that has the largest effect on lap times, to switch to a limited slip differential from a Cam and Paul style vastly improves the car's ability to accelerate out of a corner, and it minimizes the understeer. The differential internals were taken out of a Honda 4-Trax and placed into a custom-designed aluminum housing that is 53% lighter than the original differential housing. The dynamics of the acceleration of the car were modeled in MATLAB to optimize the final drive ratio to 3.7 to 1. This will provide RM21 with additional torque at the cost of top-end speed. Extensive time has been spent tuning the engine on our in-house chassis dyno with the goal to increase overall horsepower and torque, increase throttle response, and improve overall fuel efficiency. All of these factors will generate an extremely predictable power delivery. For the first time in Rensselaer Motorsport's history, we will have a digital heads-up display for the driver that is paired with an intelligent pneumatic shifting system. The heads-up display's shift light will allow the driver to shift at perfect times, and the pneumatic shifting will ensure short shift times, minimizing the time we are off the throttle. Once we optimize the performance of the car, we expect to shave entire seconds off lap times and hopefully restore RPI to its rightful place in the top 10. In addition to design that was done to shave lap times, supporting design of the cooling system and exhaust system were done. The cooling system got 33% more efficient than last year's car, and we were able to shrink the cross-sectional area of the radiator. We were also able to create a beautiful ducting made entirely by hand, which will channel air across the radiator. The exhaust header's geometries were redesigned to provide proper spacing between the 1,000-degree Fahrenheit header tubes and the firewall to ensure we don't melt it. We also changed a few tube diameters to gain some marginal mid-range torque. I would also like to thank all of our sponsors that made this engine package possible. One, Precision Valve and Automation for machining our entire differential housing, along with the hangers in a 4-day turnaround, and the uprights for the suspension. Harbeck for the SLS printing our entire intake and our newly designed electrical box. This car would not be what it was without the continued support from our sponsors, and we cannot thank you enough. Now I would like to introduce you to our business manager, Caitlin Lounsbury.
Good evening, everyone. As all of our previous members have mentioned, I'd like to say thank you for coming tonight, and we're very grateful that you're here. As Jake mentioned, I am the business manager, so I'm not going to be throwing so much technical facts at you, but I'd like to tell you some improvements the team has made in other areas. This year, we had a renewed focus on public relations, and we had a number of ways that this was exemplified. The first was with a partnership with the Office of Alumni Relations, and through that, we were able to do several events. The first was Reunion and Homecoming Weekend. We hosted 5 events over the weekend, and those included a car demonstration, an auto show, several design reviews, and open houses as well. In addition, we have more Reunion and Homecoming events planned next year, again, in conjunction with Alumni Relations. Some things down the pipeline, you guys will get a sneak peek. We are planning a car cruise, as well as, again, another auto show, and some other kind of fun secret events that we will definitely keep you guys informed of. Another event that the Office of Alumni Relations helped us coordinate was an alumni tour, actually at Bumstead just a few weeks ago. We're very grateful that some alumni that attended that tour have had the opportunity to come tonight. Another partnership that we had this year was the Office of Institute Advancement. Fundraising is a huge part of the team. We couldn't build this car if we didn't have the funds for it. So we were fortunate enough to work with Institute Advancement in their We Are Gold project. We were approved for our proposal of $9,000, and we are currently more than 50% funded. Several of you in the room have had the opportunity to donate, and we really appreciate that. Again, we couldn't build the car if we didn't have the funds. So Institute Advancement has been a wonderful partner for us in that area. Other events that we've done this year, we hosted several open houses in addition to the alumni open house. Through that, we had several former team alumni that we had never before met. From within the first 10 years of the team's history, from 1992 to 2002, we had several alumni stop by. In addition, we were fortunate enough to receive visitors from the MoHUD SCCA, Sports Car Club of Association of America, and they were fortunate enough. We have some exciting events with them planned relating to driver training, as well as a generous donation that they've already given us. On other aspects of the team's public relations, we've improved our social media presence. This year, we added Instagram, and we have increased our Facebook presence by 40% from the start of the year. So we definitely are increasing our presence there. Additionally, this year with our social media, we revamped the website thanks to our Chief Information Officer, Grayson Twig, as well as Jonathan Karsh for doing our website maintenance on that. Some other events that we have that are upcoming this year, or that have already taken place. We have a high school visit planned, actually 2 weeks from tomorrow, that will be taking place. We're going to be going to an area high school and working with their students on their science symposium. We'll also be demoing the car and giving them some simple physics lessons. Other opportunities that we've had on campus to interact either with prospective students or with some early elementary children to expose them to STEM early on were Exploring Engineering Day, which took place in February, and National Manufacturing Day, which took place in the fall semester. We do regularly attend a lot of admissions events, and I believe that if you ask certain members on the team, they will certainly tell you that they did make their decision to come to RPI because of Formula SAE. As several of the other team leaders have mentioned, we couldn't build this car if it weren't possible for our sponsors. So I'd like to just kind of give a certain shout out to several of them. They were scrolling on the screen. They've been scrolling up until now. But several of our top tier sponsors that have already been mentioned are Harbeck for our intake, Lincoln Electric for one of our welders, Precision Valve and Automation for all of the machining that they've done for us, and as Jake mentioned, in very constrained timeline. RBC Bearing continues to support us with a generous donation of our bearings for the car. Simmons Machine Tool Corporation, again, has for several years now done machining for us. You can certainly check them out at their table upstairs. I hope that you all had the opportunity to do that. Additionally, this year we were fortunate enough to receive a fully stocked Snap-on toolbox that we're very grateful for. We have put to very good use. We were very grateful that we had that opportunity, and that came to us through the school. And finally, that does lead me to our last sponsor that we'd like to thank is the school. Rensselaer Polytechnic Institute does a wonderful job of supporting us, giving us the publicity that we, desire, giving us the funds that we need, and just giving us the support. Obviously, we couldn't build this car if we didn't have the knowledge that we gain in our classes. So there are certainly certain aspects of the team that can't be taught, but we do appreciate the school. And lastly, I'd like to thank our team alumni. There are a lot of them who have certainly received several late night emails saying, why did you make this design decision? Or what did you do in this case? We couldn't do it without our team alumni. As Yuri mentioned, there's a lot of knowledge loss over the 4 years, and this year we did experience that heavily. So we're extremely grateful to the knowledge that our team alumni give us, as well as their generosity. Several of our alumni this year have donated generously through the We Are Gold campaign, or donated certain components for the car, so we're extremely grateful. And lastly, I'd like to, again, kind of repeat what I said before, but thank you so much to all of you that are here in the audience, friends, family, faculty members. A lot of us up here are running on a few hours of sleep, and we do that pretty regularly, and you put up with us, support us. This car couldn't be built without all of you. So thank you so much for showing up and showing your support for the team. At this point, I would like to invite up Dr. Day, the professor and head of the Department of Maine Aeronautical Nuclear Engineering. Thank you.
Thank you very much, and good evening to all of you, and welcome. First of all, I'd like to start by saying that I'm immensely proud of all of you. I've been an ardent fan of my 1,200 or so undergraduate students, and events such as these actually reaffirm my faith in my students. So I'd like to start, again, by thanking all of you for all the hard work that you've done. Thanks also to your family, your friends, to your supporters, to your sponsors, to the staff, Bill particularly, who has been with you and now taking his rest out there, exhausted, and of course to all of you for coming this evening. So events such as these remind us of two major things, and I'll likely quickly recount those, pointing those out to you. One is the value of experiential learning, and the other is that of healthy competition. And the two are not exclusive, but sometimes they can reinforce each other and make learning really interesting. And something that's a model that not only the school, but also the world at large is going towards more a competition-based innovation and entrepreneurship. So the first is experiential learning. You heard the depth and breadth of what they said. They talked about designing a car from scratch. They talked about building it from scratch. They talked about testing it. And then they did not stop there. They went ahead and then preached that gospel of innovation to the young minds, to the high schoolers and to the school kids. So this is just amazing. This is where the education meets excellence where classroom actually transcends to practical reality. So this is where I believe that actual education happens, not really in the classroom where they get the basics, but then they go out and actually they do things much beyond what we can teach them in the classroom. So I believe that this is where real learning happens. The other thing that actually is left out in traditional academic education is the psychology of a challenge or a competition. And that is quite intriguing. So I'm going to quickly recount a short story from Charles M. Schwab, not to confuse with Charles R. Schwab. So Charles M. Schwab was the steel magnate, and he was a protege of Andrew Carnegie. And this was recounted by Dale Carnegie, a story that happened about 100 years or so ago. So here's a master manager who brought metal and steel to the height of his powers. So one day, Charles Schwab was visiting one of his workshops, and that was underperforming. And he was talking to the manager. So what is happening? So the manager said, well, the workers would not produce, no matter how we coax and cajole them, whatever incentives you provide them. So he said, well, that was the time that the day shift was leaving and the night shift was coming in. He just accosted one of those people on the shop floor and asked, how many heats did you produce today? He said 6. So without saying a word, he just chalked the big figure 6 on the floor and left. So then the night shift came in, and they said, what's going on? Why is this figure 6 here? So the folks told him that, well, the big boss was here, and he heard that the 6 heats were produced, and he just chalked it in there. Well, the next morning, Charles Schwab walked into the shop floor, and that he saw that the 6 was erased, and there was a figure 7 on the floor. Then the morning shift came in, and they saw the 7 on the floor. And they said, so these guys, the night shift, thinks they're better than us, right? We'll show them a thing or two. So they worked very enthusiastically and very hard. And at the end of the day, they erased the 7 and chalked 10 on the floor and left. And ever since, there was no problem in that particular mill. So such is the power of competition. So the gauntlet has been thrown. The challenge has been served. Most of you have talked about sleepless nights, and I ask you to continue this effort, all right? Till you have won, because you will win. I believe that you will win, all right? And I think, and I wish you all the best and Godspeed.
Finals are canceled for the team?
Sorry?
Finals are canceled for the team?
They will win. Who here does not believe me? Raise your hands. All right. So I'm sure they will do very well. And even if you don't, in my eyes, you're all winners. All right? And with that, I'll stop. And this is my privilege to introduce the Jack Elaine S. Parker Professor of Chemical Engineering and our Dean of the School of Engineering, Professor Shekhar Karde. Thank you so much.
I know you've been patiently waiting to see what's underneath, and you've had sleepless nights, and you're standing here. So I'll keep my speech short, but I do want to make a broader point. So first of all, congratulations and welcome to your families. I know there's a number of faculty and staff here. Welcome. Industrial sponsors, thank you for your support. And maybe there are a few visitors who are considering Rensselaer as a potential school. How can you not choose Rensselaer after attending this event, right? The broader point I want to make is, if you pick up New York Times, Wall Street Journal, there's a whole range of articles being published. There's almost a national conversation about the value of higher education. Is higher education relevant? Are we going to be around 20, 30, 40 years from now, right? So just to give you a sense, perspective, this year we are celebrating 191st anniversary of Rensselaer. 2024 is our 200th anniversary. And so, we've made it through wars, depression, stock market collapses, and on, and we're here. And we're not just here, we're vibrant, we're active, we're vibrant. Now, why is that, right? I think one of the reasons is that we have been constantly innovating. We've been thinking out of the box. We are challenging ourselves. And as long as we continue to do that in education, in research, I think we're going to be around for another century and more. If you read the Rensselaer Plan 2024, you'll notice our goals are ambitious. We want to educate students who are intellectually agile, who are multiculturally sophisticated, and who have a global view. If you had a chance to talk to our students upstairs, walk through the exhibits, ask them good questions, you know how good they are, right? We want Rensselaer to be at the forefront of 21st century engineering education. And so when you think about aspects that are important, what do we think about, right? First is we pride ourselves in rigorous education that is grounded in fundamentals. And I think that is never going to change as a Rensselaer brand. But at the same time, we are integrating technology, whether it's video, whether it's YouTube, social media, to mixed and mobile gaming and reality games, to even maybe 10 years from now, cognitive computing. Maybe IBM Watson-like system will be serving as a teaching assistant in our dorms, and students will be working with the computer. When you think about engineering education, we think about hands-on education, right? So we are unveiling a number of maker, tinker, inventor laboratories. We heard about healthy obsession here. Can art fundamentally enhance engineering education? When we look at a car like that, we tell our students that it's got to function, it's got to follow a particular budget, it's got to be safe, it's got to work. But then we also heard about aesthetics, and we heard about beauty and so on, right? Communication, teamwork, leadership, cultural experiences, working with a diversity of people and from a variety of different countries. And so when I think about all of that, and when I think about the motorsport project, I think it's kind of all in one. Being part of this team, you get the whole experience. Fundamentals, check, right? You got to know the fundamentals. Latest technology, I learned that this car goes faster than the latest Porsche model. Art, we heard about the beautiful design. And so when we make products, when humans interact, when humans use these products, our students are thinking about aesthetics, beauty, art. When you have a group of 40 people working on different aspects of this car, of course, communication, leadership, teamwork is extremely important. And so it's really a fabulous project. I'm very, very proud of it. And really, when you think about great engineering education, I think this project, Rensselaer Motorsport, is one representation of it. And so now, the moment that everybody is waiting for, right? Here is the latest and the greatest car from the Rensselaer Motorsport. Yeah.
Thank you, everyone. At this point, we would like to invite all of our speakers as well as our team members up. All of you are more than welcome to take photographs. And then once we have a few moments for photographs, we'd like to invite you all to come and take a close-up look at the car. Thank you.